Okay, so what does it mean to divide a number? What exactly are we talking about? So let's think about if we were to have the number 8. And I asked you if you were going to divide, you've got 8 balls and you've got 2 kids. How many balls can each kid have to divide them evenly? So we're dividing all of these things. So one of the things that you should keep in mind when you're doing any math problem is math was derived from real world things. We look outside and we see something and we think about how many of those things are there and how many people are there and how many of those things can each person have. These are math problems. These are things you're going to do the rest of your life. So math, of all the things that you're learning, is probably the single most important thing short of being able to read and write. So math is very important. So don't let it fall behind and think that you don't need to have it, because it is something you'll use the rest of your life. So if I were to say 2 divided by, 8 divided by 2, what exactly am I saying? I'm saying that I want to take 8 and I want to divide it evenly so that I can give it to 2 people. So to write this, there's a couple ways to think about this. So to write this, what you do is you write it a little bit differently so that you can organize all your numbers and keep them all straight. So what we're going to do, instead of saying 8 divided by 2, we're going to say 2, and the way that you write this is like a straight line and then another straight line, and you say 2 divided into 8. And so what we're saying is how many times, remember times in your multiplication tables, how many times will 2 go into 8? So another way to think about that is, what would you multiply times 2 to get 8? That's why, and this is something else that you need to really think about. One of the reasons that we don't learn multiplication tables is because then you're having to think about what is 2 times what? 2 times 4, 2 times 5, 2 times 6. Why do we remember them? We learn them. We don't learn them in how do we make it work. We actually memorize that 2 times 4 is 8. And the reason we do that is because when we see a problem like this, we immediately know what the answer is. If we're having to work out what 2 times 4 is all the time, it slows down the process of figuring out what the answer to the problem is. But how would I do this with addition? Well, I would say, what is 2? That's 2 times 1 plus 2. Well, that gives me 4. It's also 2 times 2 because I have 2 2's. Plus 2, well, that gives me 6 because 2 plus 2 is 4. 4 plus 2 is 6. It's also 2 times 3 because I've got 3 number 2's. 2 plus 2 plus 2 plus 2. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. We want to know how many times 2 will go into 8. The answer is 1, 2, 3, 4. So 4 times 2 is going to give me 8. And so all I'm going to do is come up here and put a 4 on the top, and then I'm going to multiply it to make sure I'm right. So 4 times 2 is 8, and then subtract those, and it gives me 0. I have no other numbers to work with, so the answer to this problem is 4. So let's take a look at a little bit more complicated problem. Let's say, what is 64 divided by 2? Again, looking at this, that's a pretty complicated problem to think about, because I need to know how many times will 2 add together to give me 64. So I'm going to write it a little bit different way. I'm going to say instead, how many times will 2 go into 64? And by writing this out this way, it allows me to look at this thing a little bit differently. So how many times will 2 go into 6? Well, now instead of worrying about the whole problem of 64 or even 640, I'm now able to focus on one number at a time. So how many times will 2 go into 6? Well, we just did it. We said 2 plus 2 is 4, plus 2 is 6. That's 3 number 2's. Therefore, 3 times 2 is 6. And so we're going to put a 3 here. We're then going to multiply those, subtract it. It gives me 0. And now the next column, I'm going to bring it down. So now my question is not how many times does 3 go into 64, it's how many times does 2 go into 4. So 2 plus 2 gives me 4. That's 2 number 2's. So therefore 2 times 2 is 4. And so the answer to how many times will 2 go into 64 is 32. So to multiply that out, it gives me 4. Subtract it is 0. There's nothing else there. So we're done. So doing division is not hard. It does get harder when this number gets to be 204 into that number, because then I start having to think about it. But let's work another problem. Let's keep doing this until we get all of the scenarios here. So let's say, what is 369 divided by 2? Okay, so again, we're going to rewrite this problem to be 2 divided into 369. 2 will go into 3 how many times? Well, only one 2 will fit into 3, because if I have two 2's, it's 4. It's bigger than 3. So I can't multiply anything but 1 here to get 2. So I'm going to say 2 times 1 is 2. So we're going to write the 2. We're going to subtract it. 3 minus 2 is 1. And then we're going to bring the 6 down. So now we're asking, how many times does 2 go into 16? Well, let's think about that. We know that 2 plus 2 plus 2 plus 2, that's 4 2's, gives me 8. And therefore, 2 sets of these number 2's, which would be 8 number 2's, would give me 2 times 8, or 2 8's, which would be 16. So the answer to this problem is 2 times 8 is 16. Now notice I'm writing the 8 right over the top of that second number. I have to do that. If you don't do that, you're going to get very confused. So now we say 2 times 8 is 16. That adds up to 0. We bring our 9 down here, and now we're asked another question. How many times does 2 go into 9? Well, we already know the answer. We looked at it right here. 2 times 4 is 8. If we did 2 times 5, we'd be 10, which would be bigger than 9. So we have to stop at 8. So 2 times 4 is going to give us 8. So 2 times 4, we put it right over the top of the 9 because that's the number we're working with. 2 times 4 is 8. And now we're going to bring that down. So we end up with 1. And now we have a little bit of a problem. We know that 2 will go into 369 184 times, but there's something left over. We have what's called a remainder. And so we either have to just tell that we have a remainder, or we have to work the problem out into more precision. So right now, a proper answer to this would be R1, 184 with a remainder of 1. That is a proper answer to this problem. But generally, when you grow up and you start working problems that are more complicated, it's not okay to just say what the remainder is. I need an exact answer. What is the exact answer to this problem? And so to do that, what we're going to have to do is introduce what's called a decimal point into the equation. So we're going to put a decimal point on top of the bar here. So now we're looking at 184 point something. So to do this, we're going to add a 0 out here on the end of the number, and we'll keep adding zeros until we come up with an answer, or until we get tired, or until we see a repeating pattern where there's no point. So we're going to bring that 0 down here, and now we're asked, how many times will 2 go into 10? Well, there is an answer to that. If we know that 4 2's is 8, so 5 2's is going to give us 10. So 2 times 5, so on the right-hand side of this decimal, we're going to put a 5. And then 2 times 5 is 10. And now we have no remainder, so that is the exact answer to this particular problem. Now, this decimal point is introducing something that you guys use every day and you don't really think about it. So let's talk about this decimal point. And we can also talk a little bit about percentages as well. So we all know that 100 pennies equals $1. And you write a dollar like this. So 100 pennies equals $1. Well, this thought can be used all through math, and so some people have a problem thinking about percentages, but it's very simple when you start thinking about a dollar bill. There's 100 pennies that go into a dollar. Therefore, 100% is equal to 1 of something. So if I say that I have 100% of my eraser, that means I have my eraser. If I snap this eraser in half and I only give you half of it, it means that you only have 1/2. Well, in this situation, what is half of 100? Well, it's 50 pennies. So if I have 50 pennies, it means I also have 50 cents, which is 2 quarters or 5 dimes. So the point is working with money helps me to think about exactly what we're doing here with all of this. So how would I write $1.50? Well, I could spell it all out and say $1.50. But that would just get crazy if you're doing a lot of working at a sales counter and you're having to count money all day. It would be really difficult to have to write all that out like that. So another way to write this would be to write $1 a point and 50 cents. It's $1.50 or 1.5. So that decimal is there to represent something less than 1. So by putting a decimal in there, I'm saying that I don't have 1, because remember, 100% is $1. So, or 100 pennies is equal to $1. So if I have less pennies than $1, I have to put those pennies on the right-hand side of that decimal, and therefore, if I just simply write $1, 1.5, that tells me that's $1.50. And so when we're working with money or we're working with numbers in general, if we get something less than 1 is our answer, then you're going to have a decimal to represent what that less than 1 is, and then how much less it is. So let's think of one more thing. Let's say that I tell you that I want you to give me 75% of $1. Well, we know that a dollar is, let's erase this. So I want 75% of $1. So we know that 100 pennies makes up a dollar. So 75% of 100 is 75. So I know that I need 75 pennies. Well, what is another way to write that with what we just learned? It's $0.75 pennies, or 75%, or whatever it is that you're looking at. So anytime somebody starts talking about a percentage with you, think about money. Think about $1 and how many pennies it takes to get that dollar. And think about the dollar as being 1 of something. And so 75% of that 1 gives you some number less than the total. So 100 is our total in this case. So 75%, if I said 10%, that would be 10 pennies. If I said 20%, that would be 20 pennies. So if you start thinking about percentages just at the basic level, start thinking about them related to a dollar and 100 pennies, you're pretty close to understanding what percentages are doing. And when you're doing your division problems and we put that point, what we're saying is that 2 won't go directly into that number. It's a little bit less on the end. We have the, the 389 or whatever it happened to be, but then there's a point and then a smaller bit of that goes into the remaining of it. So all of it falls back to this type of thinking. So when you're reading your problems and you're going through and working your workbooks and you're figuring out a programming problem, or you're trying to figure out What percentage of your year do you spend studying? Well, if you think about that, we know that there's 365 days in a year. So let's say that you're studying in the state of Georgia. I think it's 180 days that you're supposed to study for 4 hours a day. So we have 180 days that we're supposed to study. Well, I can take 180 and divide it by the total of 1, because 365 is 1 year. So what I would do is I would take 180 divided by, so I'm going to divide 365 into 180. Well, when I go figure all that out, what I'm going to end up with is 365 won't go into 180 at all. So this is going to be 0, 0, 0. And now I'm going to have to add my point. And then I'm going to start having to put on decimals out here on the end. Well, think about that. I already told you that the point, everything on the right-hand side of that point represents a penny. And so what you're going to end up with is, as I start writing those numbers to figure out how many times, because 365 will go into 1,800. So as I start writing those numbers out there, I'm going to end up, and I'm not going to work this whole problem, but let's say that it ends up being, just to get us close, let's say it ends up being 50%. Well, as I start writing these numbers out here, this is telling me how many pennies I'm going to have out of that dollar, and therefore that's my percentage. If I just move this decimal over, it tells me what the actual percentage, how many pennies do I actually have. So if I said $1.75, how many pennies do you have? You have how many pennies are on the right-hand side of that decimal place. How many dollars do you have? They're the ones on the left-hand side of the decimal place. So calculating percentages becomes really easy when you start thinking about them like you're thinking about money.